Let's dive right into this explainer on the ethical use of AI in coding. Consider this your critical boardroom briefing on the hidden business risks and, frankly, the ethical liabilities of AI-assisted software development. Look, we really need to look past the hype of generative AI for a minute and examine the hard empirical data on what actually happens when we let large language models write our production code. We're going to uncover exactly why your traditional security tools are completely failing you right now, map out the true scope of what ethically sourced code looks like, and give you the actionable strategies you need to actually secure your AI integration. So let me ask you this. Would you deploy AI-generated code straight into your tech stack without a human ever looking at it? This is literally the ultimate question for technical leadership today. Because right now, treating AI as a replacement developer rather than just an assistant is a massive, massive trap. Research shows that while these AI tools absolutely speed up development, they're also introducing logical errors, hidden bugs, and totally incorrect assumptions. The AI simply lacks your full project background. Yet developers often feel this false sense of security, which creates a really dangerous dynamic where unverified code gets pushed straight into production. Now check out this number, 55.8%. What's really fascinating and honestly pretty alarming about this is that it represents a structural crisis. In a formal verification study of 3,500 code artifacts across 7 major LLMs, we're talking big ones like GPT-4o and Gemini 2.5 Flash, researchers found that 55.8% of AI-generated code contains at least one critical vulnerability. That means the code is literally broken by default. And these aren't just theoretical warnings either. Over 1,000 of these findings were mathematically proven to be fully exploitable. And I know what you're probably thinking. Well, I'll just tell the AI to write secure code. Actually, the crucial point here is that you cannot simply prompt your way out of this. Digging deeper into the data, researchers showed that adding explicit security instructions to your prompt reduced the vulnerability rate by a completely negligible 4 percentage points, bringing it down to 60.8%. The flaws aren't a misunderstanding of your prompt, they are literally baked into the model's training data. Because vast amounts of C and C++ code on the internet lack proper memory guards, these models have just internalized those dangerous patterns as the correct way to do things. But here is the part that should really keep you up at night. 97.8%. Traditional static application security testing, or SAS tools, are completely blind to this stuff. Industry standard tools missed 97.8% of these formally proven exploitable AI vulnerabilities. Let that sink in for a second. The exact tools your organization likely relies on every single day for compliance and security auditing are not catching the very specific types of errors that AI models are generating by default. So why is there such a massive technical disconnect? Well, traditional SAS tools rely on syntax pattern matching or path-sensitive tracking. Basically, they look for known bad shapes in the code. But they totally fail to identify integer overflows in generated dynamic allocation logic. Think of a malloc operation, because they can't compute unconstrained integer bounds. They literally don't know if the variable is safe. Formal verification, on the other hand, using tools like Z3 SMT solvers, encodes these conditions as actual mathematical formulas. It computes the arithmetic across the full domain of integer inputs, mathematically proving whether an exploit actually exists. Now, let's pivot to the supply chain, because the risk isn't just in the code the AI writes, but the dependencies it asks for. Have you heard of slop squatting? When an AI faces what's called edge domain pressure, meaning you ask it to build something super niche, it tends to hallucinate plausible-sounding package names that don't even exist. Well, attackers monitor these trends, register those hallucinated names on public repositories, and inject them with malware. It creates this massive security blind spot. If your developers are just blindly copy-pasting install commands, they are literally opening the front door for attackers. But hey, beyond direct security threats, we absolutely have to talk about legal liabilities. AI models are trained on massive data sets, right? And those often include open source repositories with really strict copyleft licenses, like the GPL. AI can seamlessly regurgitate this exact code straight into your proprietary software base. This introduces the severe risk of license tainting, where the inclusion of just a tiny snippet legally obligates you to release your entire proprietary software under those same open source terms. It is an intellectual property nightmare for any enterprise. To really grasp the full scope of this whole Trojan horse situation in the tech stack, we have to look at the ethically sourced code generation pipeline. From data collection and annotation, all the way through model training and down to post-deployment outputs, vulnerabilities and ethical breaches can be injected at literally any stage. It's not just about what the model outputs. It's entirely about how the model was built in the first place. Unethically sourced models lead directly to low-quality code, privacy violations, and massive legal risks for the organizations that deploy them. Okay, so we can actually map all these risks directly to the 11 dimensions of ethically sourced code generation, which proves that ethical failures are in fact direct business risks. For leadership alignment, let's break these down real quick. For the data itself, subject rights means opt-in consent for training data. Equity demands fair representation, and integrity means no poisoned data. For oversight, access requires public safety checks, and accountability means totally clear audit trails. Legally and technically, IP rights ensures no license tainting, and code quality demands high accuracy to avoid tech debt. And finally, the human impact. Social responsibility ensures community benefit, social acceptability respects cultural values, labor rights ensures fair wages for human data annotators, and environmental sustainability requires low-carbon energy grids. Missing even a single one of these dimensions exposes your business to cascading liabilities. So, mitigation time. What do we actually do about this? Technical leadership must immediately implement mandatory security audit protocols specifically for any AI-generated C and C++ system code. First up, you've got to integrate formal verification using Z3 SMT solvers to catch those invisible integer overflows we talked about. Second, mandate runtime testing using compiler instrumentation like GCC address sanitizer to catch memory corruption as it actually happens. And third, enforce formal human code review. Code generated by AI absolutely must be treated with the exact same scrutiny as code submitted by an untested junior developer. No exceptions. Ultimately, safely harnessing the massive productivity benefits of AI requires some very strict integration best practices. It requires a total mindset shift. You have to treat AI as an assistant, never a replacement. Isolate its suggested dependencies by running AI code in containerized sandboxes or ephemeral virtual machines. Implement prompt-driven validation loops, basically forcing the AI to verify a package actually exists before it ever writes an install command. Enforce a hybrid workflow of manual review and automated formal testing. And please, never, ever feed your live API keys or sensitive customer data into public AI prompts. The line between a massive productivity boost and a completely devastating security breach comes down entirely to your verification processes. So, what's it going to be? Are you building a Trojan horse in your tech stack, or are you empowering a genuinely secure AI assistant? Thank you so much for joining this explainer. If this briefing provided some clarity for your leadership team, please hit that like button, share it with your network, and drop a comment below letting us know exactly how your team is actively securing your AI coding workflows. Catch you next time.